Hey everyone, welcome back to the channel. Today we're diving deep, literally, into one of the most famous and active volcanoes in the United States, Mount St. Helens. You've all seen the iconic pictures from its massive 1980 eruption, the one that blew the entire top off the mountain. But what's been happening since then? And more importantly, what's going on right now underneath that crater? We've got the latest scoop, a sort of October 2025 update, based on what scientists are seeing. So, stick around, because things are getting pretty interesting deep beneath the surface. First, a quick refresher. Mount St. Helens is part of the Cascade Range, a chain of volcanoes stretching from northern California to southern British Columbia. Think of it like a line of giant soda bottles buried underground. Deep below, the Juan de Fuca tectonic plate is slowly sliding under the North American plate. As it goes deeper, the intense heat and pressure make the rock melt, creating magma. This magma is less dense than the solid rock around it, so it wants to rise, collecting in a big chamber beneath the volcano. That chamber is the engine of Mount St. Helens. After the huge 1980 eruption, the volcano didn't just go to sleep. It spent years slowly rebuilding itself from the inside out. From 2004 to 2008, it had another much slower eruption. Instead of a massive explosion, it was more like a giant rocky piston pushing up from the crater floor. This process built a new lava dome inside the crater. Imagine a thick, pasty tube of toothpaste being squeezed out very, very slowly. That's essentially what was happening. This told scientists that the magma chamber below was being refilled. So, what's the big deal for October 2025? Well, for the past decade and a half, things have been relatively quiet on the surface. But underneath, the story is completely different. Scientists at the Cascades Volcano Observatory have an incredible network of sensors all over the mountain. We're talking GPS stations that can detect ground swelling the width of a human hair, and seismometers that listen for the tiniest rumbles from deep within the earth. And what they're hearing is a constant low-level chatter. Thousands of tiny earthquakes are happening every month. Now don't panic. You can't feel these. Most are too small to even register without highly sensitive equipment, but what they tell us is crucial. They are the sound of rock cracking and shifting as magma moves around deep underground. Think of it like the creaks and groans a house makes as it settles, but on a geological scale. These quakes are concentrated a few miles beneath the surface, right where we believe the volcano's magma plumbing system is. This process is called recharge. The magma chamber that partially emptied in the last eruptions is slowly but surely filling back up. It's like a battery being recharged for future use. This isn't a sign that an eruption is about to happen tomorrow, or even next year. For a volcano like Mount St. Helens, this recharge phase can last for decades. It's a natural part of its life cycle. The GPS data backs this up perfectly. The ground around the volcano is slowly, almost imperceptibly, swelling outwards. We're talking millimeters per year. It's like the volcano is taking a slow, deep breath. This swelling is caused by the new magma pushing up from below, pressurizing the chamber and making the ground above it bulge slightly. It's a key indicator that the system is active and alive. Scientists also study the gases coming out of the volcano. Vents on the mountain, called fumaroles, are constantly releasing things like carbon dioxide, sulfur dioxide, and water vapor. By analyzing the composition and amount of these gases, geologists can get a direct sample of what's cooking down below. An increase in certain gases, especially sulfur dioxide, could be a sign that magma is rising closer to the surface. Right now, the gas levels are pretty stable and low, which is good news. It suggests the magma is still staying relatively deep. So let's put it all together for our October 2025 update. We have a consistent drumbeat of small earthquakes, slow and steady ground inflation, and stable gas emissions. What does this mean in simple terms? It means Mount St. Helens is very much alive and preparing for its next act. It's not a question of if it will erupt again, but when. However, and this is the most important part, the current activity is all background noise. It's the normal behavior for a recharging volcano. There are no signs of what scientists call precursors to an imminent eruption. Precursors would be things like swarms of larger, more frequent earthquakes moving closer to the surface, a rapid increase in ground deformation, or a big spike in gas emissions. We are not seeing any of that right now. Think of it like a pot of water on the stove. Right now the burner is on low. The water is getting warm, and you might see a few tiny bubbles forming at the bottom. That's the current state of Mount St. Helens. Before it boils over or erupts, we would expect to see the heat turned up. The water would start to rumble, big bubbles would rise, and steam would pour out. The volcano will give us plenty of warning signs before it does anything dramatic. That's why the constant monitoring is so vital. The US Geological Survey and its partners have made Mount St. Helens one of the most intensely studied volcanoes on Earth. So, the next time you see a headline about earthquakes at Mount St. Helens, you'll know what's really going on. It's not necessarily a sign of immediate danger, but a reminder that a powerful geologic engine is running deep beneath our feet. The mountain is simply recharging its batteries, getting ready for a future event that could be decades or even longer away. It's a slow, powerful, and absolutely fascinating process. Thanks for joining me on this deep dive under Mount St. Helens. It's incredible what science can tell us about the forces that shape our planet. If you found this interesting, do me a huge favor and hit that like button and subscribe for more deep dives into the world around us. Let me know in the comments what other geological wonders you'd like to explore. Stay curious, and I'll see you in the next video.